Assalamu alaikum everyone. क्या हाल है आप लोगों के? So how was the paper? I hope everyone's managed to finish it. Easy paper? Chale, I'm glad you feel that way. Lengthy paper. Yeah, it was lengthy. It was lengthy. It was lengthy and definitely a lot more difficult compared to yesterday's paper. Easy paper but lengthy paper, yes. Acha, so let's start. Let's not waste any more time. Let's get straight to work. So, acha, let's start. Then we'll talk about the difficulty level. Okay, let's start. We'll talk about the difficulty level afterwards. Before I start, I would really appreciate if you guys like the stream if you haven't done that yet, and also subscribe to the channel if you haven't done that either. ठीक हो गया? अच्छा, so let me just make sure everything's in order before I start. Just let me put my phone on charge. Another mock. No, I don't think we're going to keep a mock. Tomorrow, most likely, I'm going to keep a syllabus run through. Okay. Tomorrow, most likely, I'm going to keep a syllabus run through. Okay. Okay, so let's start. Bismillah karte hain. The first question, I think, was a bit tricky. What do you guys think? Did you guys find this question tricky? If you didn't, that's great. If you did, that's also all right. Okay, if you found the first question tricky, that's great, but if that's all right. If you didn't, that's great. So this question says, Janice is playing a computer game. She has to complete level 1 and level 2 to finish the game. Okay, yeah, just a lot of reading, So basically that was the idea, to give you guys a lot of questions that require a lot of reading and a lot of understanding, because that's a major problem in S1. Sometimes in order to be able to solve the question, you don't have to revise the question, you just have to sort of make sure that you understand it. You have to put in a lot of effort to understand the question. Now, for level 1, the probability that Janice completes it at the first attempt is 0.6. If she fails at her first attempt, the probability that that she completes it at the second attempt is 0.3. If Janice completes level 1, she immediately moves on to level 2. For level 2, the probability that Janice completes it at the first attempt is 0.4. If she fails at her first attempt, the probability that she completes it at the second attempt is 0.2. Okay, acha. Very important part is this, that she is at most allowed 2 attempts at any level. That means अगर 2 attempts से ज़्यादा उसको लग रही हैं तो फिर that's not on, that's not possible. ठीक है, ज़्यादा से ज़्यादा 2 attempts कर सकती है, उससे ज़्यादा कोई attempt नहीं कर सकती. ठीक है? Okay. Now, show that the probability that she moves on to level 2 is 0.72. Sir, if I do really good, yeah, if you do this mock really well, then unless there comes a mock which is even more difficult than this, then I can't say anything. But this mock I've made quite difficult. I made sure to make this mock quite difficult. Okay, now there are 2 ways that she moves on to level 2. That is, she completes level 1 in the first attempt. Okay, the very first attempt she does in level 1, she completes it immediately. Okay, or here is another way that she can move on to level 2. That is, in the first attempt, okay, so in the first attempt she fails. Okay, so in the first attempt of level 1, she fails the first attempt, and then when she's attempting level 1 the second time, she completes it. Okay, she fails the first attempt and then she completes the second attempt. Okay, so I repeat, one way that she can she can move on to level 2 is if she completes it in the first attempt, number 1. Number 2, another way that she can move on to level 2 is that if she fails level 1 in the first attempt but completes in the second. Okay, so that's what she has to do. She has to move on to the second level. There are 2 ways that she can do that. One is by immediately completing it, or the other is by failing it in the first attempt and then eventually completing it in the second. Yeah, you can make a tree diagram here, but the reason why I did not opt for a tree diagram is because there's not a lot of space given here. So 0.6 is the probability that she will complete it in the first attempt, which means the probability of not completing it in the first attempt would be 0.4. Okay, and then the probability that she will complete it at the second attempt is 0.3. Okay, walaikum salam. Lagging? Is this lagging? Really? So 0.6 plus 0.12 is equal to what? Is equal to 0.72. My audio is on the right instead of left. Achha, that's the first time someone's pointed that out. Is there something wrong with the audio? Please let me know. Achha, it may be lagging, but it should be fine now. Okay, it may be lagging, but it should be fine now. Abhi bhi agar if the issue persists, then please let me know. All right, now let's do part B. Part B says, find the probability that Janice finishes the game. Okay, now first let's pause and think for a second, okay, how many ways can she actually finish the game? Even if you are making a tree diagram, do we have to make it with pen? You could do that. You could do that. Okay, you could make a tree diagram using a pen, but you don't have to make, I mean, you don't have a lot of space here, honestly speaking. Okay, you don't have a lot of space here. So maybe you could do it for part C, but not for part B or part A. But so let's try and do it without the tree diagram. No, I don't do any form of guess papers, please. Okay, so you're probably here for the first time. I don't do any form of guess papers. So what are all the ways that she can finish the game? So the very first and the most obvious way is that she completes level 1 in the first attempt, and when she gets to level 2, she completes level 2 although in the first attempt as well. Okay, so that would be 0.6, the probability that she completes level 1 in the first attempt, into the probability that she completes level 2 in the first attempt, that's 0.4. Okay, but we all know, okay, that's not the only way that she can finish the game. Okay. One way is that she has to attempt level 1 twice and then she can complete level 2 in the first attempt. Okay, that's possible. Meaning that she fails level 1 in the first attempt, she completes it in the second attempt, and then as far as level 2 is concerned, she completes that in the first attempt. Okay, makes sense? So what's the probability that she fails level 1 in the first attempt? 0.4. What is the probability that she completes level 1 in the second attempt? That's 0.3. Okay, so there's a lot of data extraction that you have to do here. Then what's the probability that she completes level 2 in the first attempt? That's 0.4. Okay, बिल्कुल आप rough page पे tree diagram बना सकते हैं. That's perfectly all right. Sir, again, some pictures are coming out. Questions relation to topic of... Okay, you're going to have to explain to me what you mean by that. So now there's another way that she can complete the game. Okay, in fact, there are, I think altogether there are 4 ways. Yeah. So one is that she... Okay, so here's another way. Here's level 1, okay, which she completes in the first attempt. Okay. But then when it comes to level 2, she fails the first attempt, and then the same level she completes in the second attempt. Okay. So since this is OR, that means plus. So the probability that she completes level 1 in the first attempt, that's 0.6, multiplied by the probability that she fails level 2 in the first attempt, which will also be 0.6 because the probability that she completes it in the first attempt is 0.4. Sorry, 0.6. 0.6. Okay. Multiplied by the probability that she completes level 2 in the second attempt, which is 0.2. Okay, so level 2 complete, that means she's moved on to, she's finished the game. Okay, then there is another way. Okay, there is a fourth and the final way, which is she completes level 1 in the second attempt, okay, and she completes level 2 also in the second attempt. Okay, so what's the probability that she fails level 1 in the first attempt? We know very well, that's 0.4. Then she completes level 1 in the second attempt, probability of that is 0.3. Now, when she moves on to level 2, she doesn't complete it immediately. She doesn't complete in the first attempt. Okay, she completes it in the second attempt, which means if the probability of completing it in the first attempt is 0.4, the probability of failing it, I should have written over here, okay, what exactly is going on. So she fails the first attempt but completes it in the second. Then level 2, she fails the first attempt and completes it in the second. Okay, so what's the probability that she fails level 2 in the first attempt? That's 0.6. Then what's the probability that she completes it in the second attempt? That's 0.2. Okay. All right, so there's a lot of working, there's a lot of calculation that we have to do. So 0.24 plus 0.4 into 0.3 into 0.4. Let's work this out. 0.4 into 0.3 into 0.4. That's equal to 0.048. You can keep it in fraction form if you want. 0.6 into 0.6 into 0.2. that is equal to 0.072 plus 0.4 into 0.3 into 0.6 into 0.2, that's equal to 0.14044. Now when you add them up, let's see what you get. 0.0144 plus 0.072 plus 0.048 plus 0.24. That's equal to 234 upon 625. Now, if it's in fraction form, it's best that you leave it in fraction form. Okay? So, I'll go over this. I'll summarize this one more time. So, here's the deal. She has to come. Now, make sure that you understand the question very well. It's like you're playing a video game and you have 2 lives. 2 lives? Can we say that? Actually, just 1 life. Okay. So, level 1, she can attempt a maximum of 2 times. If she doesn't complete it, that's it, game over. Same goes for level 2. Now, what are the possible ways that she can complete this game? Well, here's one. One is that she completes game complete karne ka matlab that she completes both the levels. So she completes level 1 and she completes level 2. That's it. Game has been completed. She doesn't complete level 1 in the first attempt, but she does complete it in the second. Okay, abhi tree diagram se bhi kar deta hu. And then level 2 she completes in the first attempt. Okay. And then the other way that she can do it is that she completes level 1 in the first attempt. Okay, but level 2 she takes 2 attempts, which means she fails in the first, she completes in the second. Now, not 4 lives, Shayan. I was thinking the same. Basically, per level, you have technically 2 lives. Yeah, per level, you have 2 lives. Okay, anyway, let's not try and connect it with a video game. Okay, but anyway, then another way that she can complete this game is that she takes 2 attempts to complete level 1. That means she fails 1 attempt, she completes it in the second. And then level 2 also, same way, she fails in the first, she completes it in the second. Okay, अच्छा अब इसको ट्री डायग्राम बना के करना है तो चलें ट्री डायग्राम की इतनी जगह नहीं दी हुई वैसे ठीक है ऑल्दो आई थिंक चलो बना लेते हैं ट्री डायग्राम in case you're wondering how we can do this with the help of a tree diagram. Here it is. All right, so let's talk about level 1. Here's level 1. Okay, this is level 1. Now this is the probability that she completes. This is the probability that she fails. If she completes, the probability of that is 0.6. The probability of failing level 1 is 0.4. Okay. Now, if she completes level 1, that means she immediately moves on to level 2. So after completing level 1, these branches are representing level 2. Well, in hindsight, I think level 2 is, tree diagram is easier. I think. I'm not too sure. Now, what's the probability of completing level 2? That's 0.4. That means the probability of failing, that's 0.6. If she fails, however, she gets another attempt at level 2. Okay, and in that case, the probability of completing after failing the first attempt is 0.2. So that means 0.2, and the probability of failing would be 0.8. ठीक है? बेटा देखो rough work कौन से rough work की आप बात कर रही हैं? There is no such thing as rough work. Okay, the rough work that you're probably talking about is the kind of rough work that you will be graded for. So you don't want to do anything that you will be marked on a rough page because that's not going to be checked. Okay, or on a blank page, that's not going to be checked. जो भी आपकी relevant working है वो आप question space में ही करें. ठीक है? Okay, now, if she fails level 1, that means she's going to attempt level 1 again, and the probability that she completes it is 0.3, and the probability that she fails is 0.7. Now, if she fails level 1 twice, that's it, game over. We're not going to continue from here. Okay, but here we will continue. Okay, so once again, she's on level 2 now. Okay, so the probability that she completes level 2 in the first attempt, as we saw, is 0.4, and the probability that she fails will now be 0.6. And if she fails level 2, once again, the probability, she will get another attempt. And in that case, the probability that she completes level 2 in the first attempt would be 0.2, and she fails would be 0.8. There you go. So this is how you make a tree diagram. Okay? Just make sure that the levels are clear to you. And if you're using your tree diagram, you don't want to get confused by your own handwriting. P3, I'm streaming P3 tonight at 9:30 p.m. I'm doing complex numbers. Okay, now part C. Part C says, find the probability that Janice fails exactly 1 attempt given that she completes the game. Okay, so she fails one attempt given that she completes the game. So let's write this down first. The probability that she fails only one attempt given that she completes the game, meaning given that she finishes the game, which will mean she fails one attempt given that she finishes the game, which means she fails one attempt and she finishes the game divided by the probability that she finishes the game. Okay, now let's use the tree diagram over here. Okay, let's use the tree diagram here. P1 करवा दें बेटा, किस दुनिया में आप P1 का कल कौन से P1 का एग्जाम है? Okay, first let's find out the probability that she fails one attempt and she finishes the game. ठीक है, let's use the tree diagram for that. She fails one attempt and she finishes the game. So that could be this. Complete level 1 in the first attempt, fail level 2 in the first attempt, and then complete it. Okay, so 0.6 into 0.6 into 0.2. Okay, 0.6 into 0.6 into 0.2. Remember, what are we after? We're after Janice completing the game and only failing once in the journey. So what we have done here is basically this. Okay, level 1, level 2, level 2. Level 1 पहली attempt में complete कर लिया, फिर fail in the first, and then complete in the second. Okay, so what's the probability of that? 0.6 into 0.6 into 0.2. All right. What other way can she fail only once and complete the game? That is if she fails level 1 in the first attempt, and then she completes level 1 in the second attempt, and then she completes level 2 in the first attempt. So fail the first, complete in the second, complete in the first. So that means level 1 fail, complete, and then level 2 complete. So 0.4 into 0.3 into 0.4. अच्छा सवाल है ना? 0.4 into 0.3 into 0.4. Okay, so we'll add them up. Let's see what do we get. 0.3 2x पे पढ़ा है बेटा, मुझे भी थोड़ा सोचना पड़ता है. 0.072. So how about you come back later and watch this at 2x plus 0.048. Okay, so that's the numerator, and divide by the probability that she finishes the game, which I think we've already worked out. 234 divided by 625. That's equal to 0.3744. So 0.072 plus 0.048 divided by the answer. That's equal to 25 over 78. Okay, so the final answer is 25 over 78. ठीक है, अब देखो, please don't write this. Here's what my suggestion is. Do not write this as a decimal. If something is in fraction form, you better leave it in fraction form. ठीक है, because if something is in fraction form, that means it's the exact value. And if it's the exact value, that means you shouldn't round this off. Okay, so if you write this as 0.321, good luck trying to get full marks. You're not going to get full marks. अच्छा बेटा, अगर आपने फर्स्ट पार्ट दोबारा सुनना है तो फिर आप स्ट्रीम को पीछे करके देख लें. ठीक है, I'm going to move on now to the next part. Okay, so once again we have a question related to Janice. A lot of Janice in this paper. So this says the probability that Janice will buy an item online in any week is 0.35. Yes, the examiner will deduct mark because that's not what the answer is. 0.321 is not the answer. In probability distribution, okay, when it comes to normal distribution, that is when you round it off correct to 3 significant figures, because those answers are not exact to begin with. Okay, the answers that you get from the Z table, those are not exact to begin with. But 25 over 78 तो एक exact answer है ना. अब आप क्यों अपने पैर पे कुल्हाड़ी मारेंगे by rounding it off? Why would you do that? Okay, when it comes to finding the Z score, okay, the values from the normal distribution table, those are not exact to begin with, so those values you do round off. The marking scheme says, I wouldn't count on it. ठीक है, it does say that, not going to deny it. If it says that, it says that. but it's contradicting itself. Okay, if it does say that, it's contradicting itself. Beta, instructions per law, do yourself a favor, read the instructions. It says only round off non-exact answers. Okay, round off non-exact answers. Okay? Non-exact answers means answers that cannot be expressed in decimals, answers that answers that cannot be expressed in fraction form. Okay? All right, now question number 2, pay attention. The probability that Janice will buy an item online in any week is 0.35. Let's get through this paper, then I'll open up some examiner reports. Stick around. Once we're done with this paper, I'll show you guys some examiner reports. Janice does not buy more than one item online in any week. Okay? Find the probability that in a 10-week period she buys at most. Now, what does at most mean? What does at most mean? How do I spin pen like that? Like this. बेटा अहमद क्यों आप ऐसा कर रहे हैं? जब फ्रैक्शन में लिखने में कोई प्रॉब्लम है क्या? हाँ नहीं ना, तो फिर okay, at most means x is lesser than or equal to 7. Okay, this is what you want. Okay, which means 7, 6, 5, 4, 3, 2, 1, 0. So that's going to take forever. Okay, that's going to take forever. So instead, what we're going to do is we're going to do 1 minus the probability of x being greater than 7. Okay, and 7 means 8, 9, and 10. Yeah, that's what I can think of. Fractions se shayad koi khas masla hai. Anyway, so let's work this out. क्या कर रहा था मैं? Yeah, 10-week period. अच्छा, how do I know this is binomial, by the way? I'm sure कोई ना कोई पूछेगा कि सर आपको कैसे पता चला ये binomial है? तो मैंने सोचा मैं ही पूछ लूँ. How do I know this is binomial? 10C8, 0.35, raised to the power of 8, what's that going to be? 0.65. 10-week period. That's correct. Fixed number of trials. Good job. Plus 10C9, 0.35, raised to the power of 9, 0.65, raised to the power of 1. अच्छा, अब पता नहीं मैंने इतनी जगह छोड़ के क्यों स्टार्ट किया. Okay, then finally, plus 10C10, 0.35, raised to the power of 10, 0.65, raised to the power of 0. There you go. Number of trials are fixed, therefore it's binomial. Okay, so let's work this out. Achha, I'm just going to write down the final answer. Okay, I'm going to write down the final answer. And that is 0.995. Here we go. Same problem I also have like you, leaving space. And you know, the fact that I've been solving it on the iPad for a very long time, it's easy for me to make that adjustment, but you guys should practice on a printed paper. That's what I would recommend. Stop naming yearly full pass papers as online mocks. तो बेटा आप उसको yearly pass paper बोल के कर लिया करें, ठीक है? इसमें कोई मुश्किल काम थोड़ी है. All right, part 2. Or how about I just hide you? Why not 7, 8, 9, 10? Because it says at most 7. At most means at most means ke zyada se zyada. Like for example, if I say that you can be at most 5 minutes late, so that means till 5 is acceptable. Anything more than that is unacceptable. No, he didn't delete. I have. मैंने उसको हटा दिया. Okay. चलें आगे चलते हैं. The probability that Janice buys at least one item online in a period of n weeks is greater than 0.99. Find the smallest possible value of n. Okay, now. The probability that Janice buys at least one item. So that means probability that x is greater than or equal to 1. Okay. And what's that equal to? That's equal to 0.99. Okay. Now 1 basically means, now remember, we're still talking about the 10-week period. No, it's not geometric. Okay, it's not geometric. So here's an important part that I want you guys to pay attention to. This is part 1. Okay, and this is part 2. that means that these two are connected. Okay, this is connected with this. अगर ऐसा होता कि this was part A and then this was part B, they would be independent. Okay, part 1, part 2 means that they are basically connected. Now, greater than or equal to 1 basically means 1, 2, 3, all the way to 9, or all the way to 10 actually. Okay, which is going to take forever. So instead, what we're going to do is we're going to do 1 minus the probability of x is less than 1, which is equal to 0.99. And what is basically less than 1? Less than 1 basically means that she buys 0 items online. Okay? At least 1 item online. The opposite of that would be that she buys 0 items online. Okay? Now, how would you find out the probability that Janice buys 0 items online? It would be NC0, 0.35 raised to the power of 0, 0.65 raised to the power of n. And what's that equal to? Achha, it says greater than, sorry. It says greater than, so not equal to 0.99. We're going to write greater than. Yeah. Okay, so this is greater than 0.99. I'll explain this again. I know it's a bit tricky. I wanted to include this because this hasn't been tested in a very long time, and this by no means is a guess paper or anything. This is just something that hasn't been tested so frequently, so I thought I might test it to keep you guys on your toes. So the question says the probability that Janice buys at least 1 item online in a period of n weeks is greater than 0.99. Okay, so how many trials are we talking about? We don't know how many trials we're talking about. Okay, so we're talking about n. Acha, also, sorry, I said 10 here. This basically means we don't know the number of trials. Okay, we don't know the number of trials, so this will go on forever. Could be 20, could be 10, we don't know. This will just go on forever. Okay, so since we don't know the number of trials, we don't know the number of weeks that the question's talking about. So that means, but we do know that it's limited. Okay, we do know that it's limited. It's n number of weeks. We do know that it's limited, which means this is still binomial distribution. Okay, all right. No, it's not geometric. We don't have to use logs. We can just use trial and error, honestly. Okay, so it's still, the number of trials are still limited, which means it's still binomial. Okay, and we're going to treat it like a binomial question. Okay, so greater than or equal to 1 means we don't know what the limit is. But instead, what we can do is we can find out the opposite. We can do 1 minus the probability of x is less than 1. Less than 1, since when we're talking about integer terms, less than 1 basically means 0. Okay, so less than 1 means 0. What is the probability that she buys 0 items online? NC0, 0.35 raised to the power 0, 0.65 raised to the power of n. Now let's solve this. Let's see what we get. 1 minus 0.99, what's that equal to? That's equal to 0.01, which is greater than NC0, 0.35 raised to the power of 0 and 0.65 raised to the power of n. Okay? Now here's the deal. NC0 is 1, 0.35 is 1. So what are we looking at? We're looking at 0.01 is greater than 0.65 raised to the power of n, which means 0.65 raised to the power of n is less than 0.01. This is what we're looking at. Okay? Now here you have two options. The two options that you have is that you can do trial and error and you can use logs. ठीक है, अब logs use करने को वही लोग कह रहे होंगे जो A2 में हैं या जिन्होंने add maths पढ़ी हुई है. Okay, so I'm going to go with trial and error because I don't think everyone here has done logs. So I'm going to go with trial and error. Okay, now how am I going to do trial and error? I want you guys to have a look here. Have a look as to how I'm doing trial and error over here. If you've done logs, go ahead, use logs. I'm not going to use logs because people who haven't done logs will probably just feel inferior. So I'm just going to use trial and error. So let's use the power of 5. Is this less than 0.01? Nope, it's not. So that means when n is equals to 5, we don't get the desired result. No, I'm not going to do logs. If we use 8, we still don't get the desired result. Okay, why? Because when we use 8, we get 0.03186. But we are getting close. Okay, we are getting close. So let's try 10. Does 10 work? Nope, 10 also doesn't work. It's still not less than 0.01. Let's try 11 because we're inching towards the correct answer. So this is equal to what? When we use 11, we get 0.00875, which is clearly less than 0.01. Okay, so that means the correct answer is n is equals to 11. Okay, this is how you do it. Now I know logs is easier. Go ahead, if you want to do it with logs, please go ahead and do logs. That's perfectly all right. But the reason why I'm not using logs is because I'm pretty sure not everyone here would be aware of how logs work. Okay, so I'm not going to use logs. Simple as that. ठीक हो गया. जिसको आता है वो use कर ले. जिसको नहीं आता, it's a good sign. It's a sign that you shouldn't be using it. Okay. Mutually exclusive मैंने अभी तक देखा तो नहीं है syllabus में. It's been a very long time. I haven't seen it. I don't think it's removed from the syllabus. It's still part of the syllabus. It's simple logic. It's not exactly a concept that you have to sit down and study. It's simple logic. Sir, in probability distribution, do we have to make the denominators same? No, not necessary, but it's a good idea, especially when you have to do multiplication. It's a good idea to make denominator the same. Okay, now question number 3. Give one advantage and one disadvantage of using a box and whisker plot to represent a set of data. So one major advantage that you have of using box and whisker is that it allows you to see the spread of the data. Okay, so the advantage is that you can see the spread of the data. Now, what would be the disadvantage? Acha, wait, box and whisker. No, हाँ सही तो है. I thought stem and leaf. सही. It allows you to see the spread of the data. ठीक है. I confused it with a stem and leaf. Sorry. Disadvantage is that you can't see all the values. Okay. Disadvantage is you cannot see individual values. ठीक है. या मेरे भी जहन में पता नहीं क्यों स्टेम है. एक्चुअली यहाँ पे कहीं पे स्टेम एंड लीफ नहीं. ओके, नेवर माइंड. ऑलराइट, पार्ट 2. Advantage of stem and leaf is that you have all the values. Okay, that's a big advantage of stem and leaf. You can see all the values, and actually with the help of stem and leaf, you can also kind of see the spread of the data as well. At least you can see how it's distributed. Okay. Okay, part 2. Part 2 says, sir, ln से solve करके दिखा दें. बेटा अगर आपको ln से solve करना नहीं आता ना, so it's a sign from God that you shouldn't use ln. Okay, you should stick to trial and error. Why? Because every question where the power is unknown in S1 can be done with the help of trial and error, so stick to trial and error. Okay. Is there a disadvantage for stem and leaf? Disadvantage for stem and leaf would be, let me think. It's impractical. Okay, it's impractical and it can only be made for discrete values. If you have continuous values, it's very difficult to use stem and leaf. Okay, you can only use it for discrete values. All right, part 2. The times in minutes taken to run a marathon were recorded for a group of 13 marathon runners. Yeah, unsuitable for large data sets also. Okay. Disadvantage of box and whisker, I've written over here that you cannot see individual values. That's the disadvantage. State which of the mean, mode, or median is the most suitable measure of central tendency for these times. Explain why the other measures are less suitable. So, कोई बताएगा ये? Which one is suitable and which one is not? अच्छा बेटा, अगर आपको ट्रायल एंड एरर ज़्यादा टाइम लग रहा है तो फिर आप ln से कर लो. अब द थिंग इज़ आपको ln आता नहीं है, सो यू कांट हैव द बेस्ट ऑफ बोथ वर्ल्ड्स. ट्रायल एंड एरर करना नहीं है, ln आता नहीं है, so what are you going to do? Median? Okay. Median is definitely more suitable here. Why? If you look at the data, on one side you have 180, okay, and then you have 768. Okay, 768. So because this is an outlier, 180 you can still negotiate as not exactly an outlier, okay, but 768 is definitely an outlier. So therefore we're going to say median. Okay, median is most suitable Okay. Achha, then the question says, explain why other measures. So you don't have to write down why median is most suitable. You have to explain why the other are not suitable. Okay. So mean is not suitable as there is an outlier. Now what's the outlier? Might as well write that down. Okay. Now why is mode not suitable? Why is mode not suitable? See, the thing is, if you write median is suitable because there's an outlier, then you will have to write down the same thing for mean also. That mean is not suitable because there's an outlier. Okay. So you don't have to show why median is suitable. You only have to write down why the others are suitable. Okay, so mode is not suitable. Let's see, because is there even a mode? Is there even a mode? Yeah, because there is no value that occurs. There is no mode. Yeah, there you go. Okay, so mode is not suitable because there isn't any. Or you can say mode is not suitable as all values are unique. As all values are unique. There you go. All right, mean is affected by an outlier. Mode, there aren't any repeated values. Plus won't represent a suitable average. Yeah, there you go. What if there was a mode? Well, the reason why the question is asked is definitely because there isn't. All right, now let's move on. Achha, now the reason why I'm solving this question, I don't know, but there was someone who asked me how to calculate the interquartile range of discrete values. वो कौन था मुझे नहीं पता, but is that person here right now? Somebody asked me to explain how to calculate interquartile range of discrete values. So when I was making the mock, मुझे ख्याल आया कि चलो ये question add कर देता हूँ. With the help of this question, I'll be able to explain how to calculate the interquartile range. So who was that? Is that person here right now with us? No? नहीं वो तो मुझे पता है. It's upper quartile minus lower quartile. ठीक है. अब्दुल राफ़े, वो आप थे? चलें. So ये आप ख़ास तौर से आपके लिए मैंने ये क्वेश्चन ऐड किया ताकि मैं समझा सकूं कि ये किस तरह से एक्सप्लेन और सॉल्व करते हैं. दैट पर्सन केप्ट सेइंग 8.27 होगा तो 8 लेंगे. या एग्जैक्टली ठीक है, याद है आप लोगों को. एनीवे, सो हियर्स हाउ यू, अब मैं हूँ, चलें अब आप, खैर एनीवे, हुएवर इट वाज, हियर्स हाउ यू कैलकुलेट द इंटरक्वार्टाइल रेंज ऑफ डिस्क्रीट वैल्यूज़. ठीक है, सबसे पहले तो हम बॉक्स एंड विस्कर बना लेते हैं. ठीक है, बॉक्स एंड विस्कर में क्या आता है? Box and whisker में you have the median, you have the lower quartile, you have the upper quartile. Correct? So let's start by calculating the median. Okay. Yeah, in fact, एक काम करते हैं. Let's start by by identifying the smallest value. अच्छा, the good thing is that these values are already in ascending order. Okay, if you read these values like this, they are already in ascending order. Okay, let me just confirm that, or maybe I'm just assuming they're in ascending order. They are in ascending order. Yep, 255, 54, 60. वैसे कोई पता नहीं एग्जामिनर आपके साथ गेम कर दी ना, देखा ना. 288, 283 गेम कर दी एग्जामिनर ने. 263, 267. हाँ, कोई भरोसा नहीं करना है एग्जामिनर का. ठीक है, अच्छा तो कोई बात नहीं, हम इसको कर लेते हैं अरेंजिंग असेंडिंग ऑर्डर में अरेंज. ये किसी बहुत ही चालाक इंसान ने ना ये बनाया होगा फॉर श्योर. सो द स्मॉलेस्ट वैल्यू इज़, हाँ अगेन नॉट सॉर्टेड बिकॉज बाय द लुक्स ऑफ इट लगता है कि असेंडिंग ऑर्डर में. सो 190, लेट्स अरेंज देम इन असेंडिंग ऑर्डर नाउ. 190, 203, उसके बाद आई थिंक द स्मॉलेस्ट वैल्यू इज़ 215. ठीक है, so whatever values that I'm dealing with, I'm going to put a cross on them. Okay, then we have, no, it's not sorted. It's not sorted, please don't fall for it. But at least the good thing is that for the most part they're sorted, which I don't know if it's a good thing or a bad thing because you might end up thinking that all of it is sorted. So नहीं, ये मैंने नहीं बनाया बेटा, मैंने yearly past paper sort है. अभी कोई बोल रहा था ना कि I should call this a yearly past paper session. 246, 249. अच्छा, फिर after that we have 253. Okay, here we have 254. This is where it gets a bit crazy. 254. And then you have 255. कितने लोगों को ने actually realize किया कि this is in, we need to sort this out. Then you have 255, so we've dealt with that. 258. Okay, then you have 260, then you have 261, so cross, cross, cross. Acha, then we have to be a little bit careful once again. 261, here you have 263, so put a cross. 267, we put a cross. 269, we put a cross. 274, 276, so far so good. 274, 276, फिर होगा 280, all right. Then 283, then 287, then 280. 283, 287, then 288. Okay. Now, then after that we have 294, then we have 300. Okay, so let's cross that out. And I think the rest of the data is sorted. Rest of the values are sorted. ये column तो पूरा sorted है. ऐसे ही है ना? 7, 18, 27, 31, 36, 45, 51, 53, 60, 68, 375. चलो कोई आसान किया उन्होंने यहाँ पे. छोटा ही सही. Okay, if it doesn't affect the final answer, it's just a huge coincidence. Okay? If it doesn't affect the final answer, please don't make that a standard rule. It's just a huge coincidence. Okay, now, sorting it, it's just a huge coincidence, fellas. If it doesn't affect the final answer, it's just a huge coincidence. Don't make it a standard rule. Okay? Okay, now how many people are we talking about? We're talking about 33 people. So let's start with the median. Now, what's the median equal to? The median will be equal to 33 plus 1 divided by the 2th term. So 33 plus 1 is 34. 34 upon 2 is the 17th term. So let's see what is the 17th term. So 17th term means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so the median is 280. Acha, all those who are saying that it doesn't affect the final answer, please note that it's just a huge coincidence that it doesn't affect the final answer. Okay, it's not a standard rule that it doesn't affect the final answer. You know what? I'm going to read the examiner report of this. We'll see what the examiner report has to say. Okay, so once I'm done with this question, do remind me to open up the examiner report of this. Okay, now, Achab, here's the thing. What about the lower quartile? How will I calculate the lower quartile? So the way that we're going to calculate the lower quartile is I'm not going to use the formula. Okay, I'm not going to use the formula. I will, for lower quartile, this is the concept that I practice, and that is lower quartile is median of the first half of data. Okay, first half. So what's the first half? The first half is basically these 16 values. Okay, so the median of the first half is basically these 16 values. Now, how would you calculate the median of 16 terms? You would do 16 plus 1 upon 2. 16 plus 1 is 17. 17 upon 2, what's that equal to? Delay, really? 17 upon 2 is 8.5. So that means it's the 8.5th term. अब 8.5th term क्या होती है? 8.5th term का मतलब है that we take the average of the 8th and the 9th term. So 1, 2, 3, 4, 5, 6, 7, 8. So we take the average of these two terms. Okay, so what's the average of 255 and 258? What's that equal to? So 255 plus 258 divided by 2. So 255 plus 258 divided by 2, that's equal to 256.5. ठीक है, अब किसी का हो सकता है इसमें 256 आ रहा हो, किसी का 257 आ रहा हो. That's incorrect. The correct answer is 256.5, non-negotiable. And yes, that's correct. For cumulative frequency, we don't add 1, we just do n upon 2. Okay, now I don't recommend that formula. N plus 1 upon 4, I don't recommend that formula because in that, sometimes you'll get your answer as 0.25, sometimes 0.75. It's just a bit complicated. Okay? All right, now. Subhan, that's the thing that I want to avoid. Okay, that's the thing that I want to avoid. कि वो round off हमने कब किस पे करना है? It's not appropriate. It's not the correct way to do it. Okay, so this is the best way to do it. Now let's calculate the upper quartile. What's the upper quartile going to be? The upper quartile is going to be, once again, it's going to be the median of the second half. अब second half में कितनी terms होंगी? Second half में भी उतनी ही terms होंगी. If you have 16 in the first half, that means you will have 16 terms in the second half as well. You can count if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we'll do the same thing. We'll end up with, once again, 8.5th term. Okay, but 8.5th term counting after the median. Okay, so 8.5th term counting after the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll take the average of 327 and 331. So 327 plus 331 upon 2. Let's see what's that equal to. 327 plus 331 divided by 2. That's equal to 329. Okay, so this is how you do that. Yes, Zaryab, I also did not realize that it's not sorted. I just thought of checking, and that's when it turned out to not be sorted. Now, if that doesn't affect your final answer, don't make that a standard rule. It's just a coincidence that it doesn't affect your final answer. Acha, if you fell for the trap, then if your answers are wrong, then yes, give yourself 0. Acha, what's that? So what if formal median is like 17.5? Okay, if the formal median is 17.5 term, that means your 17th and 18th term will be your median. So the terms that lie on the left hand side of the 17th and 18th term become your first half. The terms that lie on the right hand side of the 17th and 18th term becomes your second half. That's how it works. Okay, that's a good question. कि अगर हमारा actual median ही 17.5 हो, meaning if the actual median is the median of two values, then the first half would be, like for example, let's say you have 3, 5, 7, 11, 15, 18. Okay. So right now, these two terms, the average of these two terms will make your median. Okay. So what happens is that this becomes your first half. Okay. This becomes your first half. And this becomes your second half. Okay, and this is your median. There you go. Okay. Acha, if you're using that formula 3n plus 1 upon 4, I don't know how that formula works. Okay, honestly, I've never paid attention to that formula. I especially for discrete values. Okay, especially for discrete values. For cumulative frequency and stuff like that, yes, it works. But for discrete values, this is the best way to do it. Okay, now, no, we don't have another mock tomorrow. I don't think I should take a mock tomorrow considering day after is your exam. What about 3 into LQ? What do you mean by that? See, okay, if you've done it some other way and you have a good grip on it and you're getting the correct answer, stick to that. Simple as that. The first half में 7 और second half में 11 ऐड नहीं होगा? नहीं. ओके, मीडियन के लेफ्ट हैंड साइड पे जो टर्म्स होती हैं वो फर्स्ट हाफ होता है, मीडियन के राइट हैंड साइड पे जो टर्म्स होती हैं वो सेकंड हाफ होता है. सिंपल एज दैट. Okay, now here's my suggestion. If you guys don't want to stick to this method and you have some other method and you're comfortable with it, you get the right answer with it, then stick to that. Simple as that. Okay? No pressure. All right, now let's make the what is it? Box and whisker. All right, so the smallest value is 190, the greatest value is 375. Okay, so 190 and 375. All right, so we'll have to first label. Let's start by 190. So if I do 190, 200, 210, 220, 230, 240, 250, 260, 270, 280, 290, 300. Nope, that's definitely not going to work. Okay, let's try some other scale. So let's try, or maybe instead of starting from 190, I start from 150 and then I use a scale of 50. Oops. Just a second. Yeah, I don't know why it just stops responding. Okay, so let's try one. एक सेकेंड यार. Just a minute. Just a minute. Okay, sorry about that. Now, coming back to the question, let's start by 150. Okay, so if I start by 150 and I take, let's say, a step of 50, let's see if that works. So 200, 250, 300, नहीं ये तो बहुत ज़्यादा हो जाएगा. Let's try 25. 175, 200, 225, 250, 275, 300, 325, 350, 375. Yeah, I think that works. Okay, that works. And what's the maximum value? The maximum value is 375 anyway. ठीक है. So 150, then this will be equal to 200. All right. And this will be equal to 250. This will be equal to 300, 350, 400. Yeah, let's just double check, make sure everything's on track. And while we're at it, say about okay, now you don't necessarily have to follow this scale. If it's slightly different, that's perfectly all right. Okay. Okay, so the smallest value is 190. So let's put a mark at 190. Now, where will I find 190? So as per my scale, 190 will be 2 boxes before 200. Okay, so here we will have 190. Now, what's the lower quartile? The lower quartile, as per my graph, is 256.5. Okay, now we have to be a bit careful. 256.5 we'll have to consider it close to 255. Okay, so 255, that means somewhere over here. Okay. So then we have the median. What's the median? The median is 280. Now that shouldn't be too difficult. 275, 280. There you go. So let's draw a vertical line here. Let's draw another vertical line here. Okay. Then finally the upper quartile, which is 329. Now once again, we'll have to log this at 330. So 325, one box after, that's 330. So there you go. And then the greatest value, what's that? The greatest value is 375, which should not be a problem. There you go. There you go. Okay. Now, find the interquartile range of these times. Now, we've already done all the hard work. For interquartile, it's 329 minus 256.5. So 329 minus 256.5. Let's see what's that equal to. What if it doesn't float? What do you mean? What if it doesn't float? 329 minus 256.5. What's that equal to? That's equal to 72.5. 329 minus 256.5, that's 72.5. Okay. So box and whisker takes a total of 5 points. Smallest value, greatest value, lower quartile, median, upper quartile. There you go. Okay. That's what the box and whisker plot takes. ठीक हो गया? अच्छा, अब एक काम करते हैं, इसकी ज़रा एग्जामिनर रिपोर्ट पढ़ते हैं. ठीक है. Interquartile can also be 73. No. 73. अगर आप 256 ले रहे हो तो हाँ हो सकता है. ठीक है, अगर आप 256 ले रहे हो तो हो सकता है, ठीक है, बट 256 जो है ना, देखो 256 इज़ नॉट एक्सेप्टेबल. 73 ठीक है, मार्किंग स्कीम में अलाउ किया हुआ है, ठीक है, but these are leverages that you shouldn't, these are basically leniencies that you shouldn't count on. Okay, it's acceptable, but it's a leniency that you're counting on and you're getting away with it. Okay, so the examiner has accepted 73. You're right. No, we don't have to consider y-axis in this. Amna, बेटा ये कैसा सवाल है, किस किस्म का सवाल है? आप वही है ना जो बोल रही थी 2x पे पढ़ाएं, तो बेटा ये 2x पे आई थिंक पढ़ने का नतीजा आप देख लें कि आप ऐसे अहमकाना सवाल पूछ रही हैं. इसमें y एक्सिस कहाँ पे आ गया? Okay, now paper 6 variant 2. What question number is this? This is but अब क्या करूँ? I have to sometimes make you guys realize, because if I don't do it, then who will? All right, so where were we? What question number is this? This is question number 6. Okay. Many candidates found this question challenging. Understanding when a box and whisker plot is appropriate is a required. अच्छा नहीं, ये तो वो है. Many solutions lack the accuracy required of this level with the use of inappropriate scales. Common candidates needed to ensure that any scale they used enabled them to communicate effectively their accurate values wherever possible. Most candidates found the median successfully, but the remaining quartiles were often incorrect. Okay, so this is for you guys. Most candidates found the median successfully, but the remaining quartiles were often incorrect. Okay, so ये आप लोगों की बात हो रही है जो उल्टे सीधे मेथड लगा रहे होते हैं ना, n+1 to 3/4 into 1/4 के 0.25 है तो उसको राउंड ऑफ कर लें, 0.75 है तो उसको राउंड ऑफ कर लें, ठीक है, ये सब आप लोगों के बारे में बात हो रही है कि remaining quartiles were often incorrect. Why? Because finding out the median, honestly guys, is no big deal. Okay, finding out the median is no big deal, but finding out the lower quartile and upper quartile in discrete values, that's the big deal. Okay, and that is what most people are getting wrong. Acha, also, what else? Anything important? No. That's it. Okay, so please learn how to calculate upper quartile and lower quartile of discrete data. I don't have a video on it, but it doesn't matter. You'll probably find somebody else's video, maybe Sir Zain's, maybe somebody else's. So do learn how to do it. I don't think I'll have the time to make a video, but please, जाने से पहले सीख लें. अगर पेपर में आ गया तो पछताएंगे. Do we have to add vertical lines? Yeah, of course, you have to add vertical lines as well. Okay. Okay. Question number 4. In a game, players attempt... No, I don't have a video on this topic. Like I said, I sadly don't have a video on this. Okay, but मेरी नहीं देखें, किसी और की देख लें, but please देख लें जाने से पहले. In a game, players attempt to score a goal by kicking a ball into a net. The probability that Lino scores a goal is 0.4 on any attempt. Independently of all other attempts, the random variable x denotes the number of attempts that it takes to score a goal. Not the number of goals that he scores, okay, but the number of attempts that it takes to score a goal. That means if he scores a goal in the 5th attempt, that's it, game over. Now, let's see. What is the probability that he will score a goal in his 5th attempt? How do we work that out? That means in the first 4 attempts, he's not scoring a goal. So that would be 0.6 raised to the power of 4 into 0.4. Okay? So let's work this out. 0.6 raised to the power of 4 into 0.4. Okay, so 162 divided by 3,125. Okay? Here we go. All right. Now, probability of x greater than or equal to 3, lesser than or equal to 7. Okay, so we do have to sort of work hard here a bit. So what's the probability that he takes 3 attempts to score a goal? That would be that he doesn't score a goal in the first 2 attempts, and he does score a goal in the 3rd attempt finally. Okay, plus the probability that he scores in the 4th attempt, which means he doesn't score a goal in the first 3 and does score in the 4th. Plus the probability that he does not score a goal in the first 4 attempts, and he does score in the 5th. Okay. And then second law, 0.6 raised to the power of 5 into 0.4. And finally, let's make some room here only. Zero 0.6 raised to the power of 6 into 0.4. Okay, so let's work this out. Please revise concepts of question 3 in tomorrow's syllabus review. How did you guys assume that I'm doing a syllabus review tomorrow? Let's say I am. So 0.144 plus, let's see what we get here, 0.0864. Let's see what do we get if we change 3 to 4. We get 0.05184. Let's see what happens. कल मैंने कहा था. Oops. 0.031104. Finally, let's change it to 6. So 0.01866624. अच्छा वैसे एक मजे की बात बताऊं. Sometimes in this paper, you guys might have felt that there's less mark for a lot of working. That's because I had to decrease the marks because total was exceeding 50. Okay, so there have been places where I had to decrease the number of marks because the total was exceeding 50. So 0.0864 plus 0.144. Okay, what do we get? We get 0.332. Okay. We get 0.332 0064. Okay. So because this has way too many decimal places, we will round this off, and this is what we get. Okay. अच्छा, एक और मजे की बात बताऊं आप लोगों को. I don't think anyone noticed. Did you guys checking the total marks of this paper? Yeah, that will also work. Okay, that will also work. Okay, but for that you will have to less than 3 का अलग निकालना होगा, 7 का greater than 7 का अलग निकालना होगा, फिर 1 में से माइनस करना होगा. ठीक है. When you do round off, you round off correct to 3 significant figures. Okay, when you do round off, you round off correct to 3 significant figures. Okay. All right. Now, so when we're done, we'll look at the total marks of this mock. Okay. Now part C. Yeah, 0.3320 is also acceptable. Okay. Okay. Now, but sir, for less than 3, why do we take 2 here? And so it says greater than or equal to 3, lesser than or equal to 7. Okay. That means it could be 3, it could be 4, it could be 5, it could be 6, it could be 7. So if he is completing, if he takes 3 attempts to score a goal, that means he doesn't score in the first 2 and he scores in the third. Okay. If he takes 4 attempts to score a goal, that means he doesn't score in the first 3, but he scores in the fourth. Okay. If he takes 5 attempts to score a goal, which by the way we've already worked out here. Okay. And if he takes 6 attempts to score a goal, that means he doesn't score in the first 5, but he scores in the 6th. And then finally, 7 attempts to score the first goal. That means he doesn't score in the first 6, but he does score in the fourth, in the 7th and the final one. Okay, so this basically means that we'll have to find out the probability that x is equals to 3, plus the probability that x is equals to 4, plus the probability that x is equals to 5, plus the probability that x is equals to 6. बेटा वो यहाँ पे नहीं कर सकते. Plus the probability that x equals to 7. ठीक है, वो 1 minus q हम जब करते हैं, for example, if it was just greater than or equal to 7 or lesser than or equal to 7, lesser than or equal to 7. Okay, I mean you could do that here, but I don't recommend that. Okay, you could do that कि हम पहले 3 का निकालें, कि हम इसका opposite निकालें, कि lesser than or equal to 3 and greater than or equal to 7. And then we subtract that. But you know, you're not really going to save, it's not going to make a world of a difference, honestly. Okay, you could do that, but it's really not going to make a world of a difference. Ultimately, you'll have to do the same working. So might as well do it the way that you feel the most confident, the way that it's pretty much straightforward. Okay, find the probability. All right, now this is an interesting question. Find the probability that Lino scores his second goal on or before his 5th attempt. Now first, let's try and explain to each other What does the question mean by this? ये फिर एक और एमक आ गया 2x पूछने वाला. चलो मैं इसको हाइड ही कर देता हूँ, बाद में आके देख लेना बेटा 2x पे. आमना बेटा फिर आप कोई ऐसी अहमकाना बातें करनी है. नहीं और कोई मज़े की बात नहीं है. नो मोर सरप्राइजेस. x equals to 5 plus x is less than 5. Yes. So this basically means that he could score his second goal in the second attempt, in the third attempt, in the fourth attempt, or in the fifth attempt. Okay? So that's what we have to consider over here. We have to consider the possibility that he scores his second goal on the second attempt, because it could be fifth or before. So what if he scores the goal in the second attempt? अच्छा, इसके भी आई थिंक मैंने मार्क्स कम किए थे. नहीं, ये 3 मार्क्स का ही था. ठीक है, और नहीं, इसमें से किसी के मार्क्स नहीं कम किए. So what's the probability that he scores his second goal in the second attempt? That would be goal and goal. Okay. अच्छा, I'm not ignoring. Your message probably got lost or something. Okay, so just send it again instead of crying about it. So goal and goal, that's 0.4 into 0.4. Okay. Now what's the probability that his second goal came in the third attempt? That would be if he doesn't score in the first and he scores the next two. But here's the thing. This can happen anyway. Okay, this can happen in any order. We just have to make sure that his second goal came in the third attempt. Okay, we just have to make sure that the second goal happened in the third attempt. So that means in the first two, it could be that he doesn't score a goal and he does score a goal, or it could be that he scores a goal and then he doesn't. Okay, like in third attempt mein goal lazmi hona chahiye. So this would be 0.6 into 0.4 squared, 0.4 into 0.4. And don't forget that because this can be shuffled, so we'll do 2 factorial. Okay, now what's the probability that he scores his second goal in the fourth attempt? So that would be no goal in the first, no goal in the second, goal in the third, and then a goal in the fourth. And here's the thing, this can happen in any order. Okay, this can happen in any order. बेटा फर्स्ट अटेम्प्ट में वो 2 गोल कैसे करेगा? ऐसा कैसे होगा, ज़रा मुझे समझाओ. So 0.6 squared into 0.4 squared, and don't forget for the first 3 that would be 3 factorial into 2 factorial. Okay, and then finally his second goal comes on his fifth attempt. Okay, so that would be no goal in the first, no goal in the second, okay, no goal in the third, and then finally goal in the fourth and goal in the fifth attempt. And once again, this can happen in any order, it doesn't matter. ठीक है, but जो fifth goal है वो non-negotiable. जो fifth attempt है, that's non-negotiable. Okay, so this would be 0.6 cubed into 0.4 squared, and don't forget 4 factorial divided by 3 factorial. Okay. Acha, you can treat it like a binomial distribution. You're right. You can treat it like a binomial distribution. So you get 0.16. Okay, you get 0.16. All right. Now, then 0.6. Hang on. Let me first do it like this. Then we'll explore some other methods. So this is equal to 0.192. Okay, and then 0.6 squared into 0.4 squared into 3. So this is equal to 0.1728. And then finally 0.6 cubed into 0.4 squared into 4 factorial divided by 3 factorial. So that's just as good as 4. So 0.13824. Now let's add them up. Let's see what we get. Shouldn't it be times 2 factorial in the fourth attempt? Nope. Times 3 factorial divided by 2 factorial. Okay. Now plus 0.1728 plus 0.192 plus 0.16. So what's that equal to? That's equal to 0.66304. Now because this is exact, so we'll leave it here only. 0.66304. ठीक हो गया? Okay. Now, yeah, you can do 3C1 also. Why 3 factorial? Because these 3 are the same. So there are, think of it this way, there are a total of 4 letters of which 3 are the same. So 4 factorial divided by 3 factorial. That's why. ठीक है. If you do round off, I think you get away with it. देखो, when it comes to rounding off, you will notice inconsistencies. ठीक है. But the rule is that any non-exact answer is supposed to be rounded off. Exact answers are not supposed to be rounded off, but you will always notice some inconsistencies. ठीक है. Okay, now. अच्छा, what else? Let's move on. अच्छा, मैं देख लेता हूँ marking scheme में अगर 0.663 उसने accept किया है या नहीं. I don't see why not. 0.663 is acceptable. Well, say here's my suggestion. Because this is something that can be written in fraction form. Okay, this is something जिसका आंसर ना primarily fraction form में आ रहा है. So अगर fraction form में आ रहा है ना तो फिर अपनी rounding off वाली चीज़ से जान छोड़ें and just write it in fraction form and move on. Okay. अच्छा, इसका और कोई तरीका, let me think. इसका और कोई तरीका क्या हो सकता है? इसका और कोई तरीका हो सकता है. Let me think. But again, it's not going to make a world of a difference. First, let's complete this paper and then we'll come back to it. चलो ऐसे कर लेते हैं, ठीक है? Because this paper is quite lengthy in it of itself, so let's complete it. या binomial use कर सकते हैं, ठीक है? You can use binomial, but I'm just thinking कि you will have to use binomial for 5C2, 5 attempts, 2 goals. 5C3, 5C4. We'll come back to it later. Okay, we'll come back to it later. Now, Lino has 75 attempts to score a goal. What kind are we talking about now? Okay, I'm not saying binomial is wrong. Okay, binomial you can use it and get the correct answer. Okay, but I'll have to think. Okay, binomial हम कैसे use कर सकते हैं? ठीक है. This is basically from binomial to normal. So n is 75. Okay, the probability that he scores a goal is 0.4. Okay, which means the probability that he doesn't score a goal is 0.6. Okay, so remember when you convert from binomial to normal, the mean is NP and the variance is NPQ. Well, good luck using binomial in this part. Okay, then you'll only be able to solve one question in the entire paper. So NP, that's 75 into 0.4. 75 times 0.4, that's equal to 30. Okay, into 0.6, that's equal to 18. Okay, so this is the normal distribution. All right, now, so this part is actually 5 marks. This is not, okay, negative binomial, मैंने पढ़ लिया ना, I don't have to spam. This is actually 5 marks. Okay, I've reduced it to 4 so that total जो है ना वो 50 हो जाए, तब भी 50 नहीं हुआ वैसे. Okay, now it says that more than 28. Now more than 28, more than 28 means that we will have to take 28.5. Okay, now remember more than means that we will do 1 minus phi of 28.5 minus 30 over square root of 18. Okay. Remember, we always take the standard deviation. So 28.5 minus 30 divided by square root of 18. Okay, I didn't notice that it says less than 35 also. How come nobody pointed that out? It says less than 35. I just saw more than 28. I didn't notice less than 25. So hang on. Need to fix this. Probability that x is more than 28 and less than 35. Okay, so more than 28 means 28.5, less than 35 means 34.5. So first we'll apply continuity correction. So this would be 28.5 and this would be 34.5. पीछे ice cream वाला जा रहा है. Okay, so this means that we will have to first find out phi of 34.5 minus 30 upon 18, square root of 18. Okay, and from that we will subtract phi of 28.5 minus 30 upon square root of 18. Okay, so let's work this out. So 34.5 minus 50 over square root of 18, what's that equal to? That's equal to, 30, not 50. That's equal to 1.061. 1.061. Okay, so phi of 1.061. All right, then minus, I think this will give us a negative phi value. So 28.5, yep, definitely it will give us a negative phi value. 28.5 minus 30, so this is minus 0.354. Remember to take it correct to 3 decimal places. Okay. Sir, under root of NPQ standard. हाँ तो बेटा हम formula में standard deviation ही लेते हैं. Okay, in the formula we take standard deviation. We divide by the standard deviation. All right, now this we can work out quite easily. This, however, we will have to do 1 minus phi of 0.354. Okay, so what does that mean? That means phi of 1.061 minus 1 plus phi of 0.354. Okay, so when you work this out, I'm just going to write down the final answer. Okay. So the final answer will turn out to be 0.494. ठीक है, टेबल रीड कर लीजिएगा, वैल्यूज निकाल लीजिएगा, कैलकुलेटर से चेक भी कर लीजिएगा. ओके बेटा आने दें फोटोज. ठीक है, आप अपनी पढ़ाई पे फोकस करें. Alright, now question number 5. This I would say is quite a difficult paper. Definitely a difficult paper. ठीक है. Can we write P instead of no, I would recommend that you write phi. Okay, because P means that it's probability, which it's not. Okay. All right, 3 coins A, B, and C. Yeah, when you're calculating Z values, in the end you round it off correct to 3 significant figures. Not 3 decimal places, 3 significant figures. Okay. Okay, now 3 coins are, can you draw the distribution? Yeah, I will do that. Don't worry about it. Okay. 3 coins A, B, and C are each thrown once. Okay, A, B are biased, and the probability of obtaining a head is 2 upon 3. Coin C is biased. Okay, so they're all biased. Okay. Sir, where can we get the... Did I not upload the solved version yesterday? If I didn't, I'll do it right now. Okay, I'll do it after today's class. If I didn't upload it yesterday, I'll do it after today's class. Okay, so we have A, B, and C. Let's write down the probability of getting a heads in A. That's 2 upon 3, which means the probability of tails is 1 upon 3. For B, it's the exact same thing, so just copy-paste it. And for C, however, the probability of getting a heads is 4 upon 5, which means the probability of getting a tails is 1 upon 5. Okay. Now we want to find out the probability of obtaining exactly 2 heads and 1 tail. All right. Yeah, I will upload it. Okay. I forgot. I will upload it, inshallah. I'll upload it right after today's stream, inshallah. So we want exactly 2 heads and 1 tail. So one way that can happen is that you get a heads on coin A, you get a heads on coin B, and you get a tails on coin C. Okay, the probability of which will be 2 upon 3 into 2 upon 3 into 2 upon 3 into 2 upon 3 into 4 upon 5. No, wait, into 1 upon 5. Okay, now instead of writing it here, I'll write it here. Okay, another way that this can happen is, this by the way is equals to 4 upon 15, 15 into 3, that's 45. Okay. Another way this can happen is that if you get a heads on coin, or in fact, let's say you get a tails on coin A, and the remaining coins give you a head. You get a heads on coin B, okay, and you get a tails, or you get a heads on coin C. Okay, so that would be tails on coin A, that's 1 upon 3, heads on coin B, that's 2 upon 3, into heads on coin C, which is equal to 4 upon 5. So what's that equal to? That's equal to 8 upon 45. Is there any other way this can happen? Yes, this can happen some other way also. That is, if you get a heads on coin A, you get a tails on coin B, and you get a heads on coin C. Okay. So what are we going to do? We're going to do heads on coin A, the probability of which is 2 upon 3, into tails on coin B, probability of which will be 1 upon 3. Okay, and then finally heads on coin C, probability of which is 4.5. So this would be 8 upon 45. Okay, that's it. No other way this is possible. Okay, now 4 plus 8 plus 8, that's equal to 16. 16 plus 4, that's 20. 20 upon 45, what's that equal to? Simplify using the table of 5. So 5 4s are, 5 9s are. There you go. That's the answer. Why not make a tree diagram? You can make a tree diagram if you want. Okay, why don't we multiply by 3 factorial here? Good question. Why will we not multiply by 3 factorial here? Read the question. The coins are thrown once. That's it. So that means whatever order they land in, that's it. We don't have to consider any other order. If the question said repeatedly, then you consider factorial. Okay? All right. Now, okay. Part B. Part B says the random variable x is the number of heads obtained when the 3 coins are thrown. Draw up the probability distribution table for x. No, not because they're biased. Okay, this has nothing to do whether they're biased or not. This is because you're just throwing them once. Okay, when you're throwing them repeatedly, then you consider all the arrangements. Okay, but you are only throwing them once, so you will only consider one arrangement. That's it. Okay, so we have to draw the probability distribution for x. Let's see how we can do that. Let's see how much space we have. Okay, we have plenty of space. So एक काम करते हैं. First, let's do all the working here. So we know that we can have 0 heads. All right, we can have 1 heads. Okay, we can have 2 heads. Or we can have 3 heads. Okay. Now, let's consider them one by one. Let's start with 0 heads, then we'll talk about 2 heads, then we'll talk about 3 heads. 0 head. 0 head means that we get tails from each coin, which means 1 upon 3 into 1 upon 3 into 1 upon 5. Okay, 0 heads means that you get tails from coin A, you get tails from coin B, and you get tails from coin C, which means 1 upon 3 into 1 upon 3 into 1 upon 5, which is equal to 1 upon 45. So here's the thing. Now be a little smart. Notice that we have already found the probability of getting 2 heads. Okay, we've already worked this out. We've already found the probability of getting 2 heads. That's basically equal to 20 upon 45. Okay, so we've already worked this out. Now, which one do you think would be easier? Finding the probability of getting 3 heads or finding the probability of getting 1 head? Which one do you think would be easier? This or this? Obviously, this would be easier. Okay, finding the probability of getting 3 heads will be much easier. That means you get a heads on coin A, you get a heads on coin B, and you get a heads on coin C. Okay, so if I can work this out, so this would be 2 upon 3 into 2 upon 3 into 4 upon 5. Okay, so 2 upon 3 into 2 upon 3 into 4 upon 5. So what's that equal to? That's equal to 8. 8 times 2, that's 16. So 16 upon 45. Now, why did I do this? Why did I do this to begin with? The reason why I did this is so that we can find out the easier ones, and for the difficult one, we can simply subtract it from 1. Okay, now for 1 head, I can simply subtract it from 1. So here's x, and here is the probability of x being equal to x. So 0 head, 1 head, 2 head, and 3 head. Okay, now what's the probability of getting 0 heads? That's 1 upon 45. What is the probability of getting 1 head? Okay, we haven't worked that out, but we'll work that out in a minute. The probability of getting 2 heads, that's 20 upon 45. Probability of getting 3 heads, that's 16 upon 45. Okay, so for 1 head, we will do 1 minus 1 upon 45 plus 20 upon 45 plus 16 upon 45. So 16 plus 20, that's 36. 36 plus 1 is 37. So what's 45 minus 37? That's equal to 8. So 8 upon 45. Okay, there you go. Now, let's move on let's see what's left. Achha, then you guys can work this out. I hope you guys can work this out without my help. I'll give you guys the final answer of this. Okay. I'll give you guys the final answer for this. Just a second. Sir, can we give answers with... Reason why I don't prefer that is because you can give your answer with different denominators. That's perfectly all right. But reason why I don't personally prefer that is because फिर वो calculation करना थोड़ा मुश्किल हो जाता है. That's the only reason. Okay, so variance of x. How will we figure out the variance of x? Here's how we're going to do that. So we will first take the square of every x value multiplied by their respective probability. So 0 squared into 1 upon 45 plus 1 squared into 8 upon 45. Okay, plus 2 squared into 20 upon 45 plus 3 squared into 16 upon 45. And from this, you will subtract the mean squared, which is 32 upon 15, the whole thing squared. Okay, acha, just so you guys know what the answer is, it's 136 upon 225. Okay, there you go. That's okay. If you write the simplified version, that's perfectly all right. Okay. It's perfectly all right. No, it's not a must. Okay, it's not a must. You can write it however way you want, and it's not necessary that you simplify. Okay, so let's speed things up a little. This is question number 6. I think this is the second to last question of the mock. So let's speed it up a little. I need to finish this before Maghrib. Okay, so this question says, Farmer Jones grows apples. All right. The weights in grams of the apples are grown each year are normally distributed with mean 170 and standard deviation 25. Apples that weigh between 142 and 205 grams are sold to the supermarket. Find the probability that a randomly chosen apple grown by Farmer Jones this year is to be sold to the market. Okay, now, Acha, let me see if I think I've changed some marks over here also. So anyone would like to give the answer for this? Can you please show the cases where we consider different orders during probability? So I have done a stream on discrete random variable or probability distribution. Okay, it's I did it very early. I think it was around September, October. Usme jaake check kare. I have explained that. 0.78, let's find out. So basically, only an orange that's in between 205 and 142 will be sold. Okay, so we just need to find out the probability of it. Okay, which means that first we will find out phi of 205 minus 170 over 25 minus phi of 142 minus 170 upon 25. Okay. So 205 minus 170 over 25, what's that equal to? That's equal to 1.4. So phi of 1.4 minus phi of, I think we'll end up with a negative value here. 142 minus 170 divided by 25. Yep, minus phi of 1.12. Okay. So we'll do phi of 1.4 minus 1 minus phi of 1.12, which basically means phi of 1.4 plus phi of 1.12 minus 1. Okay. Yeah, continuity correction is only applied when you're converting from binomial to normal. ठीक है, अच्छा इसका क्या आंसर आ रहा है? इसका आंसर आ रहा है 0.788. Okay, so this will be given correct because this is done from the table, from the z table. So anything done from the z table is given correct to 3 significant figures. Not 3 decimal places, 3 significant figures. Okay, then the next part says, Farmer Jones sells the apples to the supermarket at 0.2 for each. He sells apples that weigh more than 205 grams to a local shop. He does not sell apples that weigh less than 142 grams. The total number of apples grown by Farmer Jones this year is 20,000. Calculate an estimate for the total income from this year's apples. Okay, so what are we going to do? First thing that we have to do is we have to find out the probability of an apple that weighs more than 205 grams. Okay, so we have to do that. Acha, here I'm assuming you guys have already found out phi of 1.4. Anyone who has phi of 1.4 and would like to share it with me? What is phi of 1.4? क्योंकि ये हमें use करेंगे यहाँ पे. Yeah, if you write it as 0.7878, that's also all right. मिल जाएंगे marks, ठीक है. But best to follow the way that it's done. 0.9192. Okay, 0.9192. Okay, thank you. So if the probability of an apple being less than 205 grams is equal to 0.9192, what would be the probability of an apple being greater than 205 grams? That would be 1 minus 0.9192. Okay, so what's that equal to? That's equal to 1 minus 0.9192. That's equal to 0.808. Okay, so that's for one apple. Okay, how many apples are we talking about? We're talking about 20,000 apples. So we multiply this by 20,000. So 20,000, that's equal to 1616. Okay, so that's equal to 1616. And he sells them for 0.30 each. So 0.30. So what's that equal to? That's equal to 400 and... Hey, wait a minute. I think I've done something wrong. 20,000. Hey, wait. So 1 minus 0.9192 into 20,000 into... Oh, 0.0808. Okay, 0.0808. Sorry, मैंने इसको 0.808 कर दिया. But मैंने तो calculator में किया. अच्छा, he sells other also. He sells the apples. Oh, okay. Okay, ठीक है. I forgot about that. Okay, 20,000. Say into 0.30, that's equal to 484.8. Okay, so this is the income generated from the apples that are more than 205 grams. What about the income generated from these apples that are in between 205 and 142? That is basically for 0.24. So the probability is 0.788. So 0.788 for one apple multiplied by 20,000. So what's the number of apples that he sells? 0.788 into 20,000. Okay, into 0.24. So that's equal to 3782.4. Okay, so let's add them up. 484.8. So we get 4266.8. So that means the total amount of money that he makes just by selling apples is $4,266.8. There you go. Okay. Now, अच्छा, less than 142 वाले वो नहीं बेच रहा. Okay, so no amount of income generated from this. Only the ones that are in between 142 and 205. Okay, and the ones that are greater than 205. There you go. All right, now for last question. No need to. If you do round off here, that's acceptable. Okay, you do round off here, that's acceptable. Okay. So J and his wife K are having a party. J has invited 5 friends and each friend will bring his wife. At the beginning of the party, 12 people will stand in a line for a photograph. How many different arrangements are there if the 12 people, if J stands next to K and each friend stands next to his own wife? Okay, why did you not multiply by 0.24? I did multiply by 0.24. I did not just write it. I mean, I didn't write it, but I did multiply it by 0.24. ठीक है, मैं लिख देता हूँ. ठीक है, मैंने डायरेक्ट कैलकुलेटर में कर दिया था. You're right. I did multiply by 0.24. I just did not write it. Okay, sir, because if you get something right, it's going to make you lose confidence. Yeah, that's correct. So don't solve past papers tomorrow because you don't want to enter into a state of panic. That's why I gave you guys a difficult paper so that we can just close the whole past paper chapter today. All right, now here's the thing. There are 2 restrictions over here. One is that J will stand next to K. Okay. And they're a couple as well. Okay. And all the other friends will stand next to their wives. Okay. It's not a problem. So there are 12 people, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's make one box for J and K. Okay, so J and K are inside this box. They can shuffle amongst themselves. Okay, and every couple means 2 people. Okay, so the couple inside can shuffle amongst themselves. So that's 2 factorial. Here also, the couple can shuffle amongst themselves. That's 2 factorial. Okay, here also, the couple can shuffle amongst themselves. So that's 2 factorial. And then here also, the couple can shuffle amongst themselves. So that's 2 factorial. And here also, the couple can shuffle amongst themselves. That's 2 factorial. Okay. All right, if you do round off, that's fine. But the thing is, since we were getting the exact answer, so no need to round off. But if you do round off, that's fine. I'm looking at the marking scheme. They have accepted it. So basically, for J and K, we also have to do 2 factorial, right? Does it say that J stands next to K? Or anything of that sort? No, it doesn't. So 2 factorial. Now, how many times do we have to do 2 factorial? Let's see. We have to do 2 factorial. 1, 2, 3, 4, 5, 6. 6 times. So instead of doing 2 factorial times 2 factorial times 2 factorial times 2 factorial, just raise it to the power of 6. Okay. And also do not forget one thing, one very important thing, which is that as far as these couples are concerned, there's no specific order as to in which they should stand. So these couples as a couple can shuffle also. Okay, so these couples as a couple can also shuffle. And how many couples are there? There are a total of 6 couples. 1, 2, 3, 4, 5, 6. So that means we'll multiply it by 6 factorial as well. Okay, so 6 factorial for the 6 couples and 2 factorial for each couple. So what's this equal to? Let's work this out. I got 4266.18. Yeah, that's fine. That's fine. So 2 factorial raised to the power of 6 into 6 factorial. 46,080. 46,080. That's the answer. There you go. Okay. How many different arrangements are there if, of the 12 people, if J and K occupy the 2 middle positions in the line and J's 5 friends on one side and 5 wives on the other side? Okay, so that means they can be on either side. Okay, why was it to the power of 6? Because there are 6 couples. So 2 factorial times 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 2 factorial. Instead of doing it manually, just raise it to the power of 6. Okay, that's why. So once again, let's start by making 12 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now as far as J and K are concerned, J and K will occupy the 2 middle positions. Okay, so that means you will have 5 people. 1, 2, 3, 4, 5 people here. Okay, and you should have 5 people here. 1, 2, 3, 4, 5. Okay, now these people can shuffle amongst themselves. There is no restriction. Here, these 5 people can shuffle amongst themselves. Here also, these 5 people can shuffle amongst themselves. Here's J, here's K, who, by the way, can also shuffle amongst themselves. Okay, they too can shuffle amongst themselves. So that means 5 factorial into 2 factorial into 5 factorial. Correct? Those who are saying 28,800, this is why you're saying 28,800, because you probably missed one thing. 28,800 is not the final answer. So here's the thing. These are the friends. Okay, so here are the males and here are the wives. Now here the question says, read it carefully. J's 5 friends on one side and 5 wives on the other side. So that means it doesn't say that the friends should be on the left hand side and the wives should be on the right hand side or the other way around. That means both is possible. ये भी तो हो सकता है that you have the wives here and you have the friends here. That's also possible. But you will not do 3 factorial. Okay, you will not multiply it by 3 factorial. Please note that you will not multiply it by 3 factorial because J and K are fixed. So you will not multiply it by 3 factorial, but you can shuffle this. This can be shuffled. Okay, these 5 people as a group can be shuffled. As in you can have the wives first and then the friends. So for that, you'll multiply it by 2. Okay, so what's this equal to? 5 factorial into 2, 5 factorial into 2 into 5 factorial into 2. That's 57,600. Okay. All right. Acha, once again, a disclaimer. This was a 5-mark question. I changed it to 4 marks. Okay, so don't feel bad if you had to do a lot of working here. It is a 5-mark question. All right. Now, for a competition, during the party, 12 people are divided into a group of 5 people, a group of 4, and a group of 3. Find the probability. Okay, so we're talking about probability. Immediately find out the total. Okay, immediately find out the total so that you can secure some marks. So what's the total number of ways in which you can divide a group of people into 5, 4, and 3? So that would be 12C5 into 12 minus 5. What's that equal to? That's 7. 7C4 into 3C3. Okay? So 12C5 into 7C4 into 3C3, that's equal to 27,720. ठीक हो गया? Now let's put this on the side. I don't know if the answer is 19 upon 66. Let's find out. Now what is the condition? The condition is that J and K must be in the same group. Okay, that's the condition. So we have, how many groups? We have 3 groups. One is a group of 5. So 1, 2, 3, 4, 5. Then a group of 4. 1, 2, 3, 4. And then finally a group of 3. Okay. So let's call this group A, the group of 5. Let's call this group B, and let's call this group C. Okay. अच्छा अभी देख लेते हैं क्या आंसर है. Take it easy. So let's put J and K in the group of 5. Now, if they are already in this group, that means 2C2. Or whether you do 2C2 or not, makes no difference. They're already in this group, 2 people that you have to select, so that's 2C2. Okay? Maybe that is the correct answer, but we'll find out. We'll find out. Achha, now, what about the remaining 3 people? The remaining 3 people will come from the remaining 10 people. So that would be 10C3. Okay? Now, from the 12 people, 5 we've already put in a group. That means now we're down to 7 and we have to make a group of 4. And now we're down to 3 and we have to make a group of 3. Okay, so let's work this out. 2C2 को हम ignore भी कर दें तो कोई फर्क नहीं पड़ता. ठीक है. 10C3 into 7C4 into 3C3, that's equal to 4200. Okay. Now, another way this can be done is this. That we put J and K in the group B. Okay, now remember, whenever there's a restriction, you have to settle that restriction first. Okay, whenever there's a restriction, you have to settle that restriction. So the restriction is that we put J and K in group B. So that would be 2C2. Now the remaining 2 people from this group will come from the remaining 8 people because we've, not remaining 8 people, remaining 10 people. Okay, and we want 2 people in this group. Okay? Okay, now let's go back to the first group. We are now down to 8 people. We have to put them in a group of 5. So that's 8C5. And now we're down to 3 people. We have to put them in a group of 3. So that would be 3C3. Okay? Let's see what do we get. Hiba, you will lose 1 mark. So 8C5 into 10C2. That's equal to 2520. Now the last possibility. The last possibility. The last possibility is that we put them in a group of 3. Okay, so 2C2, once again, you can totally ignore this. Now you're down to 10 people. You just have to select 1, so that's 10C1. Now we go back to group A, 9 people. We're down to 9 people. We have to select 5, so that's 9C5. Into, we're down to 4 people. We have to select 4, so that's 9C4. Okay, now let me get through this question, then I'll take your questions. Okay, so 9C5 into 10C1, because 2C2 we can ignore, 4C4 we can also ignore, so this is equal to 1260. Now what's the favorable outcome? The favorable outcome is 4200 plus 2520 plus 1260 divided by the total number of outcomes, which is equal to 27,720. Let's see what do we get. 1260 plus 2520 plus 4200 divided by 27,720. That's equal to 19 upon 66. ठीक हो गया? There you go. Alishfa beta, instead of spamming, I would suggest you watch my you watch my stream of permutations and combinations, in which I haven't solved that exact question, but I have covered that concept. Okay, so please no spamming. Just watch my yesterday's stream. Achha, then there were some important questions which I should answer. A wala 10c5 or B wala 5c2? No, why would it be 10c5? Because here we do have to complete group C, right? We do have to complete group C. So what about the third member? The third member would be from the remaining 10 people. So that's 10c1. Achha, sir, can I use fraction for intermediate values? Yeah, you can do that. And in the end also, if you have your answer in fraction form, it's best that you leave it in fraction form. Okay. Sir, J and K can swap as well though. But it looks like you're using Internet Explorer. We've already solved that question. Yeah, J and K can swap. That's why we did times 2 factorial. Okay, won't J and K switch positions, so we multiply by 2 in each? I did multiply by I did multiply by 2 factorial. 10c, okay, I've already answered that. A good mark in this paper would be 35 plus. Considering the difficulty level of the question, a good mark would be 35 plus. Okay. सर अगर हमने पहले जे एंड के को ग्रुप सी में रखा अच्छा ओके आप इसकी बात करें जे ओके आई थॉट यू वर टॉकिंग अबाउट द प्रीवियस क्वेश्चन के जे एंड के कैन स्वैप ओके नो हियर वी आर टॉकिंग अबाउट पुटिंग देम इन अ ग्रुप सो even if they swap it's still the same group. Okay, so here even if they swap it's still the same group fellas, come on. Combination की बात हो रही है ना, तो अगर वो swap कर भी लें तो it's still the same group. अच्छा मैं इसको अभी अपलोड कर दूं नहीं तो मैं भूल जाऊंगा. Syllabus run through tomorrow. Suggest a good time. I was thinking around 6. सर एग्ज़ाम में क्या इस डिफ़िकल्टी लेवल की क्वेश्चन आती हैं? बेटा ऑल दीज क्वेश्चंस आर फ्रॉम पास्ट पेपर सो इट्स पॉसिबल. ओके आफ्टर Isha would be a good time. No, I want you guys to sleep around 10:30 p.m. because I think some of you have accounting on the same day. Some of you have accounting with no wait, it's not accounting. I think some of you have eco with S1. सर सेकंड ऑप्शन में 10c5 then 5c2 3c3 कर सकते हैं. हाँ ठीक है ऐसे कर लो. You change the order, that's fine, but just make sure you settle the restriction first. Okay, just make sure you settle the restriction first. Accounting is tomorrow, it's economics. ठीक है चलें. So I'm going to stop here. It's Maghrib time and I will see you guys inshallah in the next stream. Let me just quickly upload that S1 वाला mock 1 वरना मैं वो भी भूल जाऊंगा. ठीक है, so I'll stop here. I'll see you guys inshallah in the next stream which is tomorrow and tomorrow we will do a syllabus run through. ठीक है sir, you told to tell alternative way to solve one question. Okay, वो binomial की बात करें but if I do that I'll remind me tomorrow. ठीक है, remind me tomorrow. Okay, so I'll stop here. See you guys on Tuesday, which is tomorrow. Take care, everyone. Allah Hafiz. If PNC are weak, then watch permutation combination. There's an entire playlist. Make sure to check it out. Okay, Allah Hafiz.